You are given a whole number, and your job is to find the two digits inside it that multiply together to give the biggest possible product. Keep in mind, if a digit shows up more than once in the number, you are allowed to use it twice when picking your pair. So you just want to return that highest product you can make from any two digits in the number. Beginner level high. Let's start with something surprising. If you change just one digit in a number, the correct answer can jump by 60. That's because most people accidentally multiply the wrong two digits together and they don't even realize it. Don't worry if that sounds confusing right now. By the end of this video, you'll be able to spot the right two digits instantly, every time. Here's a simple trick. Finding the two biggest numbers in a group. It sounds small, but it's used in real things like game leaderboards, online auctions, and any system that needs to quickly find the best twos without checking every single number. Learning this one idea now will save you time on lots of future problems, so stick with me. Let's break this down slowly. We're given a number, say 124. First, we split it into its individual digits, 1, 2, and 4. A digit is just a single number from 0 to 9. Now, we pick any two of those digits and multiply them. We try every possible pair, 1 times 2 equals 2, 1 times 4 equals 4, and 2 times 4 equals 8. Since 8 is the biggest result, 8 is our answer. Before we write any code, let's meet three simple building blocks. A string is just text. Imagine tearing the number into little strips of paper, one digit per strip. A list is like a tray where we lay all those strips down in order. And a loop is simply a way of telling the computer, look at each strip, one at a time, from left to right. That's genuinely everything we need. No fancy tricks required. Here's the key idea, and I promise it's simpler than it sounds. Imagine a tiny leaderboard with just two spots on it, first place and second place. As we look at each digit one by one, we ask, is this number bigger than whoever's in first place? Does it belong in second place instead? Or does it not make the leaderboard at all? By the time we've looked at every digit once, our two leaderboard spots hold the two biggest digits. And we never had to compare every possible pair. Let's look at the most obvious way to solve this first, since it's the easiest to understand. We just take every possible pair of digits, one against another, using two loops nested inside each other. A loop inside a loop. We multiply each pair and keep whichever result is biggest. This works completely fine here because our number can have at most 10 digits, so it's not too slow. But it does a lot more checking than it actually needs to. And that habit can slow things down a lot on bigger inputs later on. Now let's build the smarter, faster version step by step. First, we turn our number into text so we can look at it one character at a time. Then, for each character, we turn it back into an actual number. At the end of this step, we have a neat list containing every digit of our original number. Remember our two-spot leaderboard? We create two variables called max1 and max2. These just hold numbers and they both start at 0. Now we go through the digits one at a time. For each digit we ask, is it bigger than max1, our current champion? If yes, the old champion drops down into max2 and this digit becomes the new champion in max2. If it's not bigger than max1, we ask a smaller question. Is it at least bigger than max2? If so, it takes second place. Once we have looked at every digit, max1 and max2 hold the two biggest digits we found. So all that's left is to multiply them together, and that's our final answer. To recap, we go through the list one time, keep two current best numbers updated, and multiply them at the end. That's the whole solution. Let's pause for a second before I show you the answer. Suppose our number is 22, so our digits are 2 and 2, the same digit twice. Take a moment and think, what would max1 and max2 end up being, and what's the final product? Don't worry if you're not sure. Let's work through it together next. Here's what happens, step by step. We look at the first digit, 2. It's bigger than max1, which started at 0, so max1 becomes 2. Now we look at the second digit, also 2. Is it bigger than max1, which is now 2? No. They're equal, so it doesn't win first place. But is it bigger than max2, which is still 0? Yes. So this second 2 slides into max2. Now max1 is 2 and max2 is 2, so we multiply them. 2 times 2 is 2. So we multiply them. 2 times 2 equals 4. That's why repeated digits still work correctly with this method. A really satisfying detail once you see it. Let's talk briefly about speed, in plain terms. Our new method looks at each digit exactly once and only ever needs 2 extra little boxes to remember numbers in. That's called linear time and constant space, which just means it scales really nicely even for huge lists. The first, simpler method checks every possible pair, which means the work grows much faster as the list gets longer. That's called quadratic time. For this specific problem, since the number has at most 10 digits, both methods are fast enough that you won't notice a difference. But it's a good habit to reach for the faster method whenever you can. Honestly, for this exact problem, the slower two loop method really isn't necessary. It's a habit a lot of us fall into early on, reaching for nested loops without stopping to ask if there's a simpler way. I made this exact mistake myself starting out, checking every pair when a single pass through the list was all I needed. It's a completely normal step in learning, so don't feel bad if you've done it too. Let's double check our solution actually works in a few tricky situations. If both digits are the same, like 11, we just saw that max 2 still fills in correctly, giving us 1 times 1 equals 1. If there's a 0 somewhere, like in the number 10, the answer correctly comes out to 0, since anything times 0 is 0. And no matter how many digits the number has, our loop just goes through them once. It doesn't get confused or slow down. Remember that tricky case with the number 22? Now you can see exactly why starting max 2 at 0 and letting it update even on ties makes everything work out correctly. To sum up the whole approach, split the number into digits, walk through them one time while keeping the two biggest values updated, then multiply those two values together. That's genuinely the whole trick. Nice job sticking with this one. This track the top values as you go idea is something you'll see again and again in coding, so you've just added a really useful tool to your toolbox. Tomorrow we'll build on this exact idea with a slightly trickier version involving 3 numbers instead of 2. So come back for that. If this helped you understand something new today, a like and a follow genuinely helps a lot. Thank you for learning with me.